Hi, I'm Ed Rushman. This is on adopting the new. Way back in the day, I was working for a software company, and we had a program that was about 7.5 million lines of code. We were converting it from the original language, not necessarily all of it. We were converting it from the original language to a newer language or a different language to meet some technical objectives that were needed. It wasn't really about changing what the program did. By the way, we call that refactoring, which is you're making it do the same thing it always did, but you're changing the code underneath for some reason, often for efficiency, but sometimes it's for other reasons, like adoption of a new language. Here we go. Somebody there, one of the programmers told me, he said that, so they were moving from Fortran to C, if you've ever heard of either one of these languages. And he said the problem is that they're still writing Fortran, but they're writing it in C. And what he meant is that they weren't really taking advantage of what the new language, not that it was really new at the time, but what the language could do, because they were still stuck in old patterns. What really prompted this was because I know somebody that's taking a course in Java right now, and in explaining to her about how to do things, I have to be careful that I don't drift back into old programming ways that don't necessarily work with Java. Now, I've done a fair amount of programming in Java in my time, many years ago, but I still remember. And instead of just saying how to do it, I ended up giving a little lesson on the history of it and why we do things the way we do, how we used to do it, and the advantages that this provides doing it the way in the future. If you're curious, it's because it was the idea of when you have an array of objects, it's tempting to go, oh, well, I normally if I have a lot of things, I'll put them in an array. But in Java, you can put them in collections. You can put it in a collection class. And there's some more things to it than that. But that gives you capabilities that otherwise you would have to write for yourself. And I remember going through this back, I don't know, in the late 90s, when I first started writing in Java. I was creating a system to teach engineering software methods to engineers, to mechanical engineers. I had come out of a C and Fortran and some other languages background, and so I was recreating the same techniques in this new language I was learning at the time, which was Java. But I learned quickly that really there were some new things in there and I could make this work a lot better. If I hadn't made that adoption of the new technology, I would have ended up recreating the things that were already built right into the language. So that's really a pattern that I think we can learn from. A general principle in adopting the new, whether it's a technology or a new frame of mind or anything else, is do respect the new. Don't treat the new like it's an invader, like it's something you're being forced into, even though maybe you are. Treat it as something that has promise, something that's an opportunity. There's the old thing that we don't have problems, we have opportunities. We don't have stress, we have excitement. So you have to look at things in a more positive way, and then it opens our mind up to be able to do them more effectively. In respecting it, we want to understand it. So it means there's a learning period there where you look at it, but looking at what it does to solve a problem, not at what it does relative to how we used to do it. If we don't want to necessarily start out judging it as we're learning. If we're judging it as we're learning, then we're not open to it. We're not really respecting it. We're not really understanding it. We're just setting up against something that's familiar and that we're comfortable with. And it will almost always lose if we do that. So when we look at it that way, we try to understand it, look and see, focus on the problem we're trying to solve. If I take the Java example and say, okay, I have a list of things I'm going to keep, and I want to be able to go through all those and either check them for something, or maybe I just want to print them out. Maybe I just want to show them on a screen and list them. Normally, I would do a loop, like a for loop or something. I go, okay, from here to the last item in the array, which means I have to know the size of it. I have to know how many are actually active. Give me all those, and I'm going to put them in an array, and then I'm going to say, okay, for, I equals X to this, something. depending on the language. I'm going to go through and work my way through them. But in Java, you have the collections. And in there, you're able to just say, get the next item, get the next item, get the next item until there's no more items. And it's a very, very simple way to approach it. All the management is done already in the class. So when we do it this way, somebody will say, well, wait a minute, if you're using this instead of raw programming techniques like in C, then you're not really, you're putting yourself in a position that if you have to change to another language later, you won't be able to do it easily because now you'll lose whatever this language provided. But languages tend to go forward. They don't tend to take away useful functionalities. So this kind of a concept of being able to walk through a collection of objects is not something that's probably going to go away in a different language. But if it does, in a high-level language like Java, or any high-level language, it's really providing, in a sense, almost the pseudocode if you wanted to move it to a lower language. So if I see something and it says, okay, I'm taking advantage of the, get next item or something, well, then I just have to look and see how to replicate that in the lower language or in a different language. Maybe that other language that I'm moving to does have something like this. And seeing this will make me look for it. Most of the time, whatever you need to do, there's a way to do it. I mean, it's pretty rare that you really can't. And if you can't, it usually means you don't really understand the problem very well, or you don't understand the capabilities well. So, as to the objection of, well, later on you're going to, you're not going to be able to port something, you may not need to. You might retire first. And then the other thing is that if you do, you're going to have a good orderly point to port from, and you can solve those problems at the time. And languages are not going backward as a general rule. It's a good principle of architecture that you don't, and process design, don't optimize the obsolete. Don't optimize the obsolete. If you don't really need something, there's no reason to make it more efficient. And really, we need to think about that. We need to think about, is this thing we're trying to replicate, is it still needed? In the example I used with C and Java, there were techniques that we no longer needed to use because they're built in. But with other things too, there were processes moving from manual processes to automation, and this goes way back. There were things that just didn't need to be done anymore. There's tricks that you had to do to keep from losing a piece of paper, but in data, you're not going to lose that piece of paper. There's index methods and things like that we had to do in the old days on index cards. We wouldn't necessarily translate those index cards into code. I remember this back in the 80s. I remember the first programming I did. One of the first ones was creating an index card system. But in a database, with databases the way they are now and everything, there's other methods, and you wouldn't actually go through and necessarily reproduce everything that's on a card. There's other ways to do it. I mean, there's keyword searches now, which you couldn't do before. We had to have a card system just for keyword searches, but you don't need those now. They're handled in code in a different way, or in the database. Really, it relates to process transformation. We always want to eliminate handoff points, and that's true within code as well, but really in anything. Every time something transfers responsibility, every time something hands off a piece of information, a transaction, a customer. I mean, if you go into a store, and boy, have I ever had this happen, or you get on a call to customer service, and they say, oh, I don't know the answer to that. Let me go get somebody for you. And then they get somebody else on the line and they say, well, I don't really know. Let me go get somebody. And then they just keep handing you on until hopefully you get to the right person. Why do we have those intermediate steps? What could we have done to eliminate those intermediate steps? That's just basic process design, process optimization. Process optimization is part of it's cutting out the steps that don't really serve any useful purpose. Ideally, when somebody calls customer service, you're able to get them to the right person right away. Two ways to accomplish that. You can send them always to a very highly trained person that has a really comprehensive understanding, but that person's going to be more expensive, And you're going to have a lot of them if you put them on the very first part of the call. The other side of it is that you have a faster routing system so that the first person can get you to the last person right away without all the intermediate steps. All this is lovely. You can't always do these things, especially where human beings are concerned. Think about success criteria. Think about what we're really trying to do. It's not so much about reproducing the pieces of the old thing in the new as it is achieving what we desire from the new. And you'll notice I didn't say achieve what we had before, because we're going to a new technology, we're going to a new process, we're going to something new because we think it's going to be better. And if it's going to be better, then our success criteria have really changed. Because what's the area of improvement? Is it faster? Is it more reliable? Does it have a lower resource cost? Whatever that change is, that has now set the bar higher. And if the bar is set higher, that's where we want to aim with the new technology. Now let's assume for the moment that the new technology was put in place for that purpose. Well, then it's even more important that we make sure we keep our focus there. What we don't want to do is have our focus wander or get lost in some technical detail and say, well, wait a minute, how are we going to do this? No. You're going to just think about how to achieve the success criteria and work toward that. Maybe it takes a complete transformation. Maybe it's a complete redesign. I don't know. I've seen that. I've certainly done it. But sometimes it isn't really that major. It's just that when you're moving from one to the other, that you do need to keep in mind that you have new criteria, and the criteria are all that matters. Now, if there's anything that we did before that doesn't really serve that new criteria, that's a candidate to be eliminated. What you have now isn't perfect. Your starting point, when you're making a transformation to something new technology, new process, start with the understanding that what you have now isn't perfect. Everything can be improved. And most technical things can be reduced. There's usually something in there that doesn't need to be there anymore. When you're moving from old technology to new, depending on the degree of the change, a lot of the time, you're dealing really with a lot of fixes over time that were applied to an old system. In the old language or just in the old product or whatever. A lot of fixes, a lot of changes have been made. Sometimes there's some workarounds, all that kind of thing. This is the opportunity to eliminate those. Not by focusing so much on the workaround, but again, what's the shortest path to solution using the new technology? The old technology, the old approach informs us, and it helps us remember what needs to be done, what needs to be there. But only to the degree that it serves the final purpose, that it achieves the success criteria. So always start by assuming that we can reduce. And in some cases, we will map the old to the new. We might map old data to new data. We might have some functionality where the old design really is fine, and we really do implement the old technique in the new technology. Not everything that we knew yesterday is useless today. Human beings don't work that way. We build on the past. But we also do have to know, as human beings or as engineers or as anything else, we have to know when to let go of the past too. That's equally important. But there's people that take the extreme view. It's either I'm going to hold on to yesterday or I'm going to just move to the future and discard yesterday. And neither one of those are really sensible. We have to make judgments about it. We have to decide how we want to handle it. When you're adopting new technology, 3 things. Stay focused on the success criteria. What's the end result? And it's probably something better than what you had, so you can't just carry forward the old success criteria. What do you really have to have when you come out of this at the end? Begin with the end in mind, as someone said. Second is always reduce. You can always reduce. You can always improve. Nothing that we have is perfect. We can always move towards something better. There's always an opportunity to do it better all the time. If you don't believe that opportunity is there, it means that what you think that what you have is perfect, and I hope you know better than that. Don't optimize what's obsolete. If we don't need it, if it doesn't serve the purpose, get rid of it. Thank you. I look forward to your comments. I know this is a fast presentation, but let me know your thoughts, and I'd be glad to answer you. Thank you.